Is it a door wedge? Part of a roof? No, it is a triangular garden with a path around it. So in our triangular garden, we're given the ratio of the sides, so it's a 3, 4, 5 triangle. So that means 3, 4, 5, but that's just the ratio. We're not told that it's 3 meters by 4 by 5 meters. So let's introduce some variable, let's call it y. And so these are in a ratio of 3, 4, 5, but their length is unknown. Right? It could be really long, could be really short, we don't know. We do know that the path is 1 meter wide. So, I mean, if this diagram was to scale, we could say that this length is about 5 or 6 meters. But it might not be. Cool. What else? We're given at each corner of the garden, right? The path curves around on a sector, right? And the radius of that circle is 1 meter as well, so it's the same as the width of the path. The difference between twice the total area of the path and the area of the garden is 2 pi meters squared. And we need to find the length of the longest side. So we're looking for this length here, right, which is 5y according to our ratio. So if we know y, we can then just multiply that by 5 and we have our length. So where to begin? Well, just looking at this, we are given some concrete information about the area as 2 pi, but that's the difference between twice the total area of the path and the area of the garden. So let's try find expressions for the area of the path and the area of the garden. So just starting with the area of the garden, since we've already defined the lengths of the triangle, that might be a bit easier. So let's do that now. So area garden is that dark shaded gray, so that's half times base times height, right? Area of a triangle, where the base in this case is 4y and the height is 3y, which becomes half times 12y squared, which is 6y squared. So we have the area of the garden in terms of this unknown variable y, which we introduced at the start. Now the area of the path. So looking at it, the white area, so like these rectangles, will be pretty easy because it's a width of 1 and we know the length is the same as each length of the triangle. So area path is 1 times, right, 3y is that rectangle area, plus 1 times 4y is the bottom, plus 1 times 5y is the top. And in maths, right, we don't need to write the 1, so that's 3y plus 4y plus 5y is 12y. But what about these little sectors on the end here, right, these part circles? So if we just look closely, so the bottom left, that's a quarter of a circle. Okay, we could work that out. We could work out these angles and use area of a sector. But think what happens when if we shrink this triangle to like a point, right? This sector will combine with this sector because they're parallel, right? These lines are parallel. That's parallel. That's parallel. So that would form one complete circle. You could also do the argument of exterior angles of a triangle add up to 360 degrees. It's just, again, at a point, 360 degrees, so we have one full circle. So to the area of the path, which is 12y, we will add the area of one circle, because these all have the same radius. So pi times the radius squared, where the radius is 1. So that's 12y plus pi for the area of the path. All right, now we can tackle this line here to incorporate that 2 pi. Right, we want to use that information. So the difference between, so that means we're going to take one expression and subtract another expression. So let's go, so the difference between twice the total area of the path, so twice area path and area garden is equal to 2 pi. Right, and we've got expressions for area of the path and area of the garden, so let's substitute those in. So 2 times 12y plus pi minus 6y squared equals 2 pi. Let's expand the bracket, so that's 24y plus 2 pi minus 6y squared equals 2 pi. We could subtract 2 pi from both sides. 24y minus 6y squared equals 0. What else? We could divide both sides by 6. Yeah, that simplifies it a bit. So 4y minus y squared equals 0. And now we have a quadratic equation. And now we can solve for y. So to solve this, you could use your calculator. I'm just going to factorize because I see they both have a y. And we're left with 4 minus y. And so either y equals 0 or 4 minus y equals 0. In other words, y equals 4. Great. Now, can y equal 0? Doesn't really make sense, right? We wouldn't have a garden. We'd just have a circular path. That's a circle. So we can ignore y equals 0. So using y equals 4, we can now calculate the longest side of the garden, right? That was the task. So the longest side is 5y. So longest side is 5 times y. We know y is 4, so 5 times 4 is 20 meters. Awesome. So just to recap this one, at the start, the problem did look a bit challenging, but we straight away used this ratio. So I wrote 3, 4, 5. We've seen 3, 4, 5 triangles before, but since we don't know the exact length, instead of 3, 4, 5, we wrote 3y, 4y, 5y. We then used those variables, those expressions, to express the area of the path and the area of the garden, so that we could use this information about the difference, 2 pi. Right, so that was here, which then let us form a quadratic equation, which we solved for y. And then using y, we were able to find the longest side.